Okay, pre-calculus. This is Mr. Butterfield.
Hello, everyone.
Yeah. I got a little.
I'm Peter Griffin.
Yeah, I'm so bored at home. I've got a Family Guy soundboard here that I can play with at the same time. I'm gonna have some fun with this. I believe.
Yes.
Yeah. This is gonna be good. This is gonna be good. Here, listen to this kind of stuff. This is gonna be good.
No. I don't think so.
Yeah. I can have some fun with this. All right, here we go. I'm on page 9 of the notes, Unit 8, Day 3, verifying trig identities. You're going to practice verifying trig identities. So everything we did in 8.1 and 8.2 comes into play here. The only thing that's going to be a little bit different is they're going to basically tell you what you should end up with. So some of you guys are really going to like that because some of you guys have been attacking these things and you kind of have that feeling like, well, I don't know if I'm finished. I don't know if this is simplified. I don't know if this is what they want. Now you're going to know what they want. Okay. So that's going to be a little bit of a difference here. Here are some guidelines of verifying. Now, anytime you see the word verifying, that's what we're doing here. So you take what you learned in 8.1 and 8.2, and then you use that to do the verifying stuff. Only work with one side of the equation. Box it, circle it, whatever it takes. That's going to be highly, highly important for us. Only work on one side of the equation. Never perform a single operation to both sides. All right, so you don't do anything to both sides. So like if you have 3x is equal to 9 and you say, all right, divide 3 on both sides in algebra, you don't do that. No, you don't do that stuff. Oh, Peter Griffin's got to have something for me.
No.
Yeah, all right, that was kind of simple.
No.
That was really simple too. But basically you don't do that to both sides of an equation. Look for techniques that we studied. Use factoring. You can add the fractions. You can do FOIL. All the stuff that we did in 8.1 and 8.2. Be on the lookout for your identities. Look on the sheet. Obviously, you're going to use the tangent, sine over cosine. You're going to use tangent, cosine over sine. But those Pythagorean identities are going to be huge in this section and doing this kind of stuff. All right. As a last resort, convert everything to sines and cosines when you're really, really stuck. Oh, God. I can name names right now. Don't just sit there and stare at the problem. All right. You gotta try something. Even past that leads to dead ends will give you some insight. So if something leads to a dead end, if you're working on it and it's just getting worse and worse and worse, well, that's when you kind of gotta back up.
I just want you to know what you did the other day was wrong.
Yeah, and then that means you just gotta back up and try the whole thing all over again. All right. Let's see. Oh, he's got one that says mistake. What is mistake?
My mistake. I'll take care of this.
All right. So here we go. In example 1, verifying. All right. If you got to verify this, the problem is always going to be, I'm trying to look at, oh, here it is. I overlooked this part. Start with the more complicated looking side. So the more complicated looking side is obviously the left-hand side. We want to end. We want it to end. We want to match. We want to match the right-hand side where it says sine squared theta. So you take a look at secant squared theta minus 1, and you have secant squared on the bottom. No, you cannot just cancel those out. That's like basic arithmetic. If I have x minus 1 over x, no. That's where you kill kittens, if you remember that idea. We don't want to do that kind of thing. You take secant squared minus 1. That's got to be one of our Pythagorean identities. Secant squared, and if I subtract 1, can be replaced with tangent squared. So that's what we're going to start with. We're going to take this, we're going to replace it with tangent squared theta. That's over secant squared theta. Notice I didn't do anything to this right-hand side. Just leave it. Don't ever try to do same thing to both sides. That's algebra type work. That's not what we're doing here. Next part. We're going to take tangent squared and we're going to make that into a fraction. And that's going to be sine squared over cosine squared. Secant on the bottom, let's make that into a fraction. So this is like what they said last. Convert to sines and cosines, that's what we're doing here. Secant squared is the reciprocal. Secant is a reciprocal of cosine squared. All right, so I got sine squared over cosine squared divided by 1 over cosine squared. Remember, if you're dividing fractions, you're going to multiply the reciprocal. You get sine squared over cosine squared. Take this, multiply the reciprocal, it'll be cosine squared over 1. You can see it happening. You do the simplifying. You get sine squared, throw your theta back in there. and then you are finished. It matches what you were trying to get to, and that makes it a whole lot easier. All right, what does Peter Griffin have to say about that?
Awesome.
All right, great. That's awesome. All right, now, next part. Let me get a new color here. All right. Ooh. Ooh, what is it? Ooh.
Oh, okay.
All right. So some of you guys get the idea of what that looks like right there. Okay, verifying. You got sine theta over 1 plus cosine and cosine over sine. Let's see. Taking a look at it. We want all this complicated part. We're going to rewrite this part. Nothing comes to mind. Nothing cancels out right away. I think all we're going to do is get the lowest common denominator and get them into one fraction. So lowest common denominator would be this times this. So it's going to be 1 plus cosine times sine. All right, what does that mean? That means on the right-hand side needs to be multiplied by what's missing. 1 plus cosine, top and bottom, top and bottom. And on the left-hand side, I just need to multiply it by sine, both top and bottom. Now this will give me sine squared theta. Slide that up a little. Sine squared theta over the LCD. 1 plus cosine theta times sine theta. Plus, and then at the top, I won't distribute it right away, but I got cosine theta 1 plus cosine theta all over my LCD. 1 plus cosine theta sine theta. All right, now, if I add like terms together, let's see, if I add like terms together here, no, not yet. Let's distribute. That would give me cosine plus cosine squared. All right, now if I add like terms together, let's see what we're going to get. We're going to get, I'm going to get 1 plus cosine theta times sine theta on the bottom. All right, but on the top, I don't see where it's, now it's coming to me now. I got sine theta plus cosine theta plus cosine squared theta. Now, for a minute there, I was thinking, it had to be something that factors on the top, and that's what was making me feel stumped. And this is very natural. You're going to get to those points, and you're going to feel like you're stumped. And for a moment there, I was thinking, all right, I made it too complicated. But anytime you can get sine squared and cosine squared added together, you look at your trig identity, sine squared plus cosine squared is equal to 1. So these two, if you just put those two together, let me draw this down here, you're going to get 1 plus cosine theta. And that's what the top is going to simplify. And at the bottom, I got 1 plus cosine theta. All right, now I see where it's going now. And sine theta. So this top, because you got sine squared plus cosine squared, it's almost like I could just flip-flop these two. Put cosine squared here and cosine there. Sine squared plus cosine squared equals 1. So this plus this is 1. And then cosine theta goes here. Now this top is one factor. That's one factor. Now they cancel. And I get 1 over sine theta. 1 over sine theta. 1 over sine theta, we all know, is the reciprocal of cosecant theta. And what we have, folks, is a match. Oh, man, I like that.
It was my understanding that there would be no questions asked.
Oh, there'd be no questions.
This is awesome.
This is awesome, yeah.
Ah, sweet.
Yeah, we got it right. We got it right. Oh, this feels good.
Yeah.
All right, now, turn the page over. Like anytime we do these kind of, they tend to get a little more complicated at the end. This next one here, I think there's 2 ways to do this one, all right? So everybody's going to be doing this on their own, and I know some of you guys are going to be asking each other for help and stuff like that, or coming to me for help, but this one right here, example 3, can be done 2 different ways. The first way that came to mind for me is that both of these could be switched out. We want it to match, all right? We want it to match negative tangent squared. So tangent theta plus 1, if you look at your trig identities here, tangent theta, all right, plus 1 is equal to secant squared theta. That's an easy replacement. Cosine squared minus 1. Now, in order to get it to be cosine squared minus 1, I got to subtract 1 and then subtract sine squared. So this replacement would be a negative sine squared theta. Negative sine squared theta. All right, now, these two things put together. Now, I got my negative sign that I'm looking for right here. I'm going to take secant squared. You're going to take secant squared and make it a reciprocal. We're going to go 1 over. Secant is 1 over cosine squared theta times, and then we'll make this negative sine squared theta over 1. You multiply those two things together, you're going to get a negative sine squared theta over cosine squared theta, and that equals negative tangent squared theta, and it matches. Okay? Or there's a whole other way. All right, so this is the first way. This is the second way. Either way is fine. But the second way, and I think the second way is the way this problem was intended. The second way is to use FOIL. All right, was to use FOIL. So if you actually multiply this out, you go tangent times cosine, tangent squared, cosine squared will give you tangent squared, I'll leave out theta for right now, cosine squared. Then tangent times negative 1 would give me negative tangent squared. All right, and then 1 times cosine would give me a positive cosine squared. And then 1 times negative 1 is negative 1. So if I FOILed it out, it would look like this. And for a moment, man, that does look like chaos. But tangent is the same thing as sine squared over cosine squared. And when you multiply these two things together, the cosines would cancel out because it would be over 1. And you would get sine squared minus tan squared plus cosine squared minus 1. And we just had this happen on the previous page, on the previous example problem. But anytime you get sine squared plus cosine squared, like I could rearrange this, I can take cosine squared, put it out in front, add it. Sine squared plus cosine squared, we know that equals 1 minus tan squared minus 1. And then you have 1 and a negative 1, and they cancel out, and you're left with negative tangent squared. Put theta back in there. So there's two different ways to verify it. A group of kids may be doing it this way, and you can end up with the right answer. You can do it this way. You can end up with the right answer. Some ways are easier than others. These both feel about the same amount of difficulty level. Maybe this one's a little more difficult. I believe, whatever teacher typed this one up, I believe that's what they wanted you to try, because they even mentioned FOIL in the directions on the previous page. All right, any questions there? No? All right, let's see.
Yeah, that's what I'm talking about.
Yeah. All right, let's see. Does this sound
That
good?
sounds good to me.
Sounds good to you. All right. Let's see. Well, I think we're good. Let's get back to it.
Well, I best be getting to work.
All right, here we go. Next part. This is one whole factor. So don't think of like 1 is a factor and negative sign is another factor. These are full factors, and we want it to come out to equal 2 times secant squared alpha. That little symbol is called alpha. So your LCD is going to be 1 times the other, and they're difference of squares. So you know when you multiply them together, you're going to get something squared minus something squared. So my LCD is 1 minus sine and 1 plus sine. I'll leave alpha out of there for right now. This side, multiply it by 1 plus sine alpha. 1 plus sine alpha, top and bottom. This one needs 1 minus sine alpha. And 1 minus sine. So we did a bunch of these in sections 8.1 and 8.2. Now, and what's nice is they put a 1 on top. That makes it awfully nice. So take 1 times 1 plus sine. You get 1 plus sine on the top. And on the bottom is my LCD. 1 plus sine times 1 minus sine. We'll FOIL that out in just a minute for a difference of squares. This times 1 gives me 1 minus sine. And on the bottom, I get 1 plus sine and 1 minus sine. Oh, sounds good. All right, now, combine like terms. 1 plus 1. I just heard myself smack my lips. And if I keep smacking my lips, and you guys got to hear it, my mouth is really close to the phone level. It's got to be driving you guys nuts. I got to try that out. Peter Griffin, give me something to say. Give me something to say there.
No.
All right. Well, that's good. All right. Now, 1 plus 1 is a 2. Sine minus sine cancels each other out. So all I'm left with is a 2 on top, and that's good because I need to end up with a 2. On the bottom, if I FOIL this out, it's difference of squares. The middle terms would give me a positive sine and then a minus sine, and they would cancel out. So 1 times 1, and then sine times negative sine is negative sine squared. Now 1 minus sine squared is definitely going to fit one of our identities right here at the top of the Pythagorean identities. If I subtract cosine, I'm sorry, take that back. If I subtract sine squared to the other side, it equals cosine squared. So all of this is going to equal cosine squared. And 2 over cosine squared is the same thing as having 2 times 1 over cosine squared. That means I'm going to get 2 times secant squared. Now put alpha back in there. Oh, ho, 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 ho.
Yeah!
Yeah, it feels good.
Ah, sweet!
Feels good. All right, I'm feeling good about this now. All right, here we go. Last one. Should be our toughest one. All of this crazy mess has to come out to just equal the number 1 on the right-hand side. So again, you always work with the more complicated side. We want it to match. We want it to match just a simple number 1. This is not going to give us difference of squares this time. All right, but we're going to do the same thing that we did up above. All right, my LCD, lowest common denominator, is going to be that cosecant x plus 1 multiply by sine x plus 1. So left-hand side, I need to multiply the top and the bottom by what's missing. So sine x plus 1, sine x plus 1. On the right-hand side, I got to multiply by what's missing. Cosecant x plus 1 and cosecant x plus 1. All right, again, they made it really nice. They put 1s on the top. So 1 times that is going to give me sine x plus 1 plus 1. On the bottom, sine x plus 1, cosecant x plus 1. Now, it's not difference of squares, but they are reciprocals, so they will have a little bit of canceling. We'll get to that later on. 1 times cosecant x plus 1. I should have left x's out, but I may as well continue what I'm doing. This times this gives me the sine x plus 1 times cosecant x plus 1. Did I do something wrong here? No, it looks good. All right, now we're going to combine like terms going back and forth. The top up there, though, doesn't look like it simplifies anything really good here. Let's see what happens. Sine plus cosine. So I get sine plus, I said cosine, but it's cosecant. And then 1 plus 1 is 2. This, when you multiply all this together here at the bottom, if I FOIL this out, I'm going to do the math work down here. If I FOIL all this stuff out, I'm going to get, so I'm trying to see, I don't see where it's going to match, but let's see what happens. Sine times cosecant. So sine times cosecant, remember this is 1 over sine. So sine times 1 over sine is going to equal 1. And then I get plus sine x. All right, and then I get plus cosecant x. And then 1 times 1, forgot my 1 here. 1 times 1 is 1. Oh, I never saw it coming, but when you combine all these terms, you're going to get sine x plus cosecant x, and 1 plus 1 is 2. And none of this can be factored on top. None of it can be factored on the bottom. That's considered all one factor. That's considered all one factor. But oh, looky. Oh, looky.
That sounds good to me.
Yeah. You're going to get a cancellation, and it's going to equal 1. Bam. I feel pretty good about this. We're at the 20-minute mark, and that's as long as I wanted these videos to go. The homework assignment is pretty simple. All I want you to do is watch the video. I want you to take notes, copy the notes down in your own packet. You take a picture of the front, take a picture of the back, make sure I can read it. And your assignment is that you filled in your note packet. On the next day of class this week is when I'll do an example. I'll do some examples, and then I'll give you a new homework assignment. I haven't quite decided if it's going to be from the packet or not, but I'll give you a new homework assignment, and then that's not due until the following week. If you got any questions about this video, let me know. Ian, this is when I usually tell you to like get off your phone or something like that, but you actually need to use your phone a little bit. I'll ask if there's any questions. Ian might say something like,
I'm sorry, I wasn't paying attention. Can you start over?
Yeah, that's not going to happen right now. You can rewind the video and do the whole thing yourself. Oh, I've had a lot of fun with this Peter Griffin thing, but that's good. We're done.
All right, take it easy.
Take it easy, everybody, and let me know if you have any questions.